we have looked at just what a concave lens is, so now let's start looking at ray tracing. And we will begin with a concave lens, object, outside the focal length. Now I don't get a convenient shape for this one, but a concave lens looks like this. I'm going to represent it with a rectangle. So here we go, a concave lens. And we'll keep that in blue to be a lens. And is as narrow as I can make it. And then draw in some axes. So here is the center line for the lens. And here, this can be our principal optical axis, and this is a concave lens. So I want to draw in a couple of things like the focal length. I'm going to give this thing a focal length of 24 centimeters. I'm trying to work this out to be able to get whole numbers. 24 centimeters with a concave lens. So let me mark that spot first. Okay, I labeled this spot, and this is 24 dots. With a concave lens, it's my actual focal point that's over here on the left, and it's my reflection that's over here on the right. So the right side is primed, the left side is not. With a concave lens, it was the opposite. While I marked a focal length over here on the left side, it was just because I needed to know whether I was inside or outside that. Remember, with a convex lens, my light rays were coming together at a focal point out here, which is why the focal point was on the right side. With a concave lens, my light rays come in like this, and then they diverge outward. But if I trace them back, it looks like the focal point is over here on the left. So with a concave lens, my focal point, my actual F, is on the left, my F prime is on the right. And now I want to put my object somewhere. I'm going to put it at 40 dots, which puts me here. And I will go, let's see how tall. I know how this one turns out. So I'm going to start this one out with a very tall object. So my object height I drew as 16 centimeters. My object distance I am saying is 40 centimeters. My focal length is going to be 24 centimeters, but it's negative because it's on the wrong side. Let me label that actually. Over here. Looking ahead just a little bit. Now, when I want to do my ray tracing, I'm going to do the same thing as before. I'm going to have ray 1 go parallel to my axis, then through the focal point. So I'm going to go parallel to my axis, and then through the focal point. Now the focal point's back here. So to go through my focal point, I have to do something like that, and there is my exiting ray. Ray 2 goes through F prime, then goes parallel. So it's going to go through F prime, which would be here, but it only makes it as far as that. And then from there, it's going to go parallel. So that's my ray 2. Rays 1 and 2 are not going to cross each other. Here is the outgoing ray 1. Rays 1 and 2 are not going to cross each other. There's 1. Here's 2. So now I'm going to do the backwards tracing. Here's ray 1 tracing backwards. So I'm going to call that my 1 prime, but I'm going to label it here. And here's ray 2 tracing backwards. Call that my 2 prime. And those two cross at this location. Where they cross, that's going to be my image formation, which is right here. So this is my image. My image distance, if I measure this out, is right here, 15, and I'm on the left side of the lens, so it's a negative 15 centimeters. My image height is 6 centimeters, and it's positive because it's upright. Now I'm going to get rid of this background and take a good look at this. My image formed is virtual. It is upright. And it's reduced. I'm going to check my magnification. My magnification I know is HI over HO. So 16 centimeters is my HO. 6 centimeters is my HI. 6 over 16 is 3/8 is 0.375. It is a positive number, which tells me my image is upright, and that's correct. It's less than 1, and that tells me that my image is diminished. If I were eyeballing this, I would probably say it looks like, I don't know, a half, maybe a little less than a half, so I could estimate this from ray tracing, even if I didn't have a good way of actually measuring everything out and straight lines and everything. I could do like a quick version of this and say, well, my magnification is going to look something like this. I might not get the position exactly right or the height exactly right, but something like a half, and that'll get me close enough for something like a multiple choice test to figure out what's up. I want to double check my magnification on distances, so I know I need a negative DI over DO. So I'm going to get a negative 15 over 40. I have negative, those cancel, so I'm left with 15 over 40. 15 over 40 reduces to 3 over 8, which is 0.375. So that checks out. That is the image formation by a concave lens when my object is outside the focal length.